Again, final is 60 questions. Here's what we're going to, this is kind of the order that they're going to be in, so let's go ahead and go. They're just going to go in order as you guys see them. The first one being order of operations. I'm going to go at like a decent fast pace. If you guys have any questions or slowing down, let me know. I'll be more than happy to do those. And they jump around from the review that I've given you. So this is all from the review that is posted with you guys. I'm going to go and write this one down. This one definitely comes from the parentheses, or from, please excuse my dear Aunt Sally, parentheses, exponents, multiply, divide, add, subtract. Every single time we do one of these, you want to do them in order, okay? You want to be able to do them in order. So the first one that we're going to look up here is I'm going to go ahead and do my 8 minus 5, which is 3, and we're going to rewrite everything. And some of you guys don't need to, but I'm going to go ahead and do that every time. So this is parentheses, okay? Then we want to look at, again, we have parentheses one more time, which is in our square brackets. Within that square brackets, we have to do order of operations within there. And that tells me I want to do my parentheses, then multiplication. So 3 times 3 is 9. I'm going to rewrite everything. And we got to do parentheses one last time with our outer brackets here. And then we're going to do addition. So 9 and 2 is going to give me 11. Rewriting everything, 14 minus 4. Then I'm going to do multiplication. 14 minus 44. And then 14 minus 44 is negative 30. Want to be able to do PEMDAS in order. And one note that I'll put here is redo order of op every time. Two, I would say work in, out. Work in, then outward. And those are a gift for you to kind of review and do. Those are going to be the kind of key parts about those. Questions, comments, concerns? Easy enough? Okay. Moving on. Next one that you have on here, you do have a distributive property. And this is kind of the distributive property combined like term. So we're going to do 2 problems like this. We always say we distribute the outside number to the inside number. The outside number will be multiplied to every number on the inside. So 2x and negative 5y. So 4 times 2x would give me 8x. 4 times negative 5y would be negative 20y. Then we're just going to drop this minus 3x. What can I get for you guys? Okay. We're going to go ahead and join our terms, our 8x and our minus 3x. This will give me 5x minus 20y. Distribute is our first key. And then number 2 would be to join like terms. And I would say ends the same way. So there is one problem on your test that does have distributive property and combined like terms. Okay. Good? Keep it going? Are we okay? Okay. We're going to keep on going. Our combined like terms, what I would say and hammer away for you guys on this is know how to do this one. Definitely know how to do number 9. Because it's very comprehensive and it has you do just a whole range of it. And I'm going to kind of write off to the side 6 times a minus 2b plus 3 for a plus b. So we want to be able to distribute all the way in the beginning. So our 6 to our a, our 6 to our negative 12, our 2b. So 6a minus 12b. Then we're going to go ahead and do our plus 3 to our 4a and our b. So plus 12a plus 3b. And one step would just be to say distribute. And 2 would just be to CLT, which is my term of saying combine like terms, CLT. The like terms in this case are going to be our 6a and our 12a because they end in the exact same a here and a there. So we'll say 18a. And then we also want to do our negative 12b and our 3b. So negative 12 plus 3b will give me negative 9b. These cannot be reduced because these are not the same variable endings. So we leave it. In this case, 18a minus 9b would be C. Questions? You okay? Go ahead. What's your question if you have one? And don't feel dumb because this is a great time to review. Don't feel dumb at all. There's no dumb question in here. So in this case right here, in my answer, I'm going to do it in red here. My negative 12b and my plus 3b. This would give me negative 12b plus 3b. If you just have the whole numbers, negative 12 plus 3 would be what? Right, and we still have the variable here, so we just say b. And that's where that one comes in. Cool? I'm okay with that. Let's clarify it now. Let's get you a good grade, right? Yeah. Okay, here we go. Are we okay to continue? Okay. Beautiful problem. This is a great problem to know. A really good problem to know. You will have several questions. I want to say 6 of the 12 questions of part 1 is made up of solving equations. The hardest one being something that looks like this. So you have a 2-step one and you have a 1-step one. Yes. Don't call Mexico after midnight. And that's what we're going to copy down right now. And that's the order that I actually am going to do it in. To solve equations like this, the acronym that we were taught, and I taught my students this, was don't call Mexico. I'm going to put the X in the parentheses after midnight. And I'll tell you as we do these what the acronyms mean. And I'm going to go ahead and do this here. But this is a lot of what makes up the first part of the part of the test. Excuse me. Okay, so the first part of this, and we know it's a solving problem because we have our equal sign. Our equal sign tells me it's going to equal a value. So this is where the don't call Mexico after midnight kind of takes in place. The first part being don't, which stands for the D right there in the beginning, which is distribute. Okay, distribute. So in this case, I'm going to do my distributive property. Do here, 3x minus 6 plus 5. We'll just drop that 5 is equal to, and then we have our 2. So we're going to get 2x minus 8. Okay, and we're done there. We did distributive property on both sides. The next part that we're going to look at and do, okay, following this don't call Mexico after midnight, is our call number. The C in call means combine like terms. Our combine like terms is going to be crucial when doing this and solving. We do it to each side. So in this case, I have this side I want to take care of and this side I want to take care of. The left side, I have this -6 and the 5 that are like terms. So 3x minus 1 is equal to 10x minus 8. Can't be reduced because they are not like terms. So we leave it there. I'm going to go and erase this a little bit just so we can see it. Okay. The Mexico portion is our next bout, where the Mexico, the M and the X, it's not multiply, it means move X value. Okay, in this case, the smallest X value will always help out. My X value in this case happens to mean my 3X, so I'm going to subtract 3X. I'm going to move it to the other side. Our 3X and 3X are going to cancel out. Minus 1 is equal to 7x minus 8. We're done with that Mexico portion. Okay. The next one we're going to do is our after, which means to add or subtract in that order, whatever comes first. In this case, we have our x's to one side, so I want to get that whole number to the other side. So I'm going to add 8. Add 8 is going to give me 7 is equal to 7x. And then our last part and the best part of this all is being able to solve this out in our midnight. The M and the D are what we want to look at, which is multiply or divide, which in this case it's multiplying by 7. So to undo it, we got to divide out by 7. So in this case, our value will be equal to 1. Very crucial step. So orders of operations kind of come into play there. Distributive property comes into play there. Combined like terms comes into play there. Just almost everything. But being able to solve out is crucial. We always do the opposite operation to solve out. Questions at all on that? We're okay? Good? You guys okay? Okay. Let me help these guys out one more, and then I'll help you guys out. Okay, here we go. We're going to go ahead and do our next one. This is the last one kind of leading up to it, which is our inequalities. The inequality portion of this that I'll kind of explain is there's just several key ideas that less than or greater than are open circle. Meaning it's going to look something like this or something like this. Less than or equal to, greater than or equal to is closed. Don't you miss this a little bit? We have an open or closed circle when we do it on our number line. The hint from this, or the note, or we'll just say hint, is we're going to go ahead and say that multiply or divide by a negative flips the sign. And the one thing that I'll say to this is we flip the sign when variables on the left are variables on the right. You do have like 3 problems on there, or 3 or 4 problems, 3 problems that deal with inequalities alone. One of them is being able just to analyze them, and the other one is just graphing it. So just tell me, oh, if x is less than 3, what is it going to be? So this is a 2-step inequality problem. You solve them just as you would don't call max go after midnight. Distribute, don't have to do. Combine like terms, we don't have to do. Move small value of x, we don't have to do. So in this case, it's just add, subtract, multiply, divide. So we're going to go ahead and add 5 to both sides because we're going to add it to get rid of it on one of the sides. Our 5 and 5 go away. We're left with 2x is greater than 12. Sorry, is that, yeah, 12. Ooh. And then our last step would be to divide out by 2 to isolate our x. So 2's are going to cancel out. X is going to be greater than 6. It's an open circle going to the right because my variable's on the left, so I'm okay with that. And it would be on my number line where 6 would be. In this case, it would be D. Good stuff? Mom, we doing okay? Okay. You let me know, we'll stop. I want you to do good. So you come in and help us out. Okay, here we go. Okay, understanding slope. So go and copy that down real quick. Give me a quick little graph if you guys can. Okay, so looking at my problem here, we're going to kind of do 2 things at once. So I'm going to cover 1 and 2 here, fairly in the same way. The slope of this, so we have so many different ranges for slope. Slope is your y's over your x, your x's. We also say it's the change in y over the change in x. I like to show the visual representation. It's the up and down versus your left and right. And I also do the formula, the y2 minus y1 equals x2 minus x1. And the last part of it is a variable that it represents is m. So all those are pretty much the same. Okay, we're all talking about slope. We're all talking about, you know, what it means to have the rise over the run. One of the things that we talked about too, the 2 ways of how to graph this and to show slope is the slope formula. Which is m is equal to y2 minus y1, x2 minus x1. And the other one, when you're looking at this, would be the triangle method. And I think Mr. Jealous and Mr. Vessup showed you guys. I know I showed you guys this. Okay. When looking at this slope formula, we also talked about Mr. Slope, where he told you Mr. Slope kind of had an idea that if the arrow was going upwards, it was a positive slope. If the slope was going downwards, it was considered negative. If your line was going up and down, we considered that undefined or big U. And then if your line was going left and right, we had a slope of 0. So that's just to kind of help you out a little bit, just determining. In this case, my slope is going forward or upward, so I know it has to be positive. Okay, I know it has to be positive. I'm going to show you both ways. I'm going to show you both the slope formula for this and just being able to use the triangle method. There's 2 ways of how you want to do it. If you're just more comfortable using formulas, plug it in, you're done. I'm going to do it the long way first. I'm going to do it the short way after that. The long way being taking our 2 points, -2, -2, 2, 1, and plugging them into my slope formula. So I'm going to go y2 minus y1 over x2 minus x1. If you were to solve this out, keep, change, flip would give you -3. Keep, change, flip would give you -4. So my slope is 3 over 4. And I know you guys can plug this into your calculator. You guys will be allowed calculators on this. God, that orange smells good. It's so pungent. Like, I'm sorry. Do you smell it over there? I smell like right here, and I'm this. Oh, I'm sorry. No, it's okay. Like, you can, yeah. No, I'm okay. Huh? You can't smell it? Oh, man, it smells like, oof. Oh. Ooh. I do. Oranges are my favorite. Oranges are my favorite. Sorry. Okay. Looking at this one, so that's one method of showing you how to get the slope. The triangle method is using the graph directly. It's a little bit easier. But in this case, I'm going to make a triangle out of my 2 points. And I know that slope is always going to be my y's over my x's, so my rise over my run. So I'm rising up 3, going up 3, which is my top number, and over, if I count that, over 4. So I know that my bottom number is 4. Again, 3 over 4 is the same thing. So we're okay with that. Okay? Pretty straightforward. There's several tests, there's several questions on the quiz. You have a slope formula problem. You'll have a graphing problem that will say, what's the slope of this? So definitely know how to do slope. Slope is very key on this. I want to say at least 3 questions that you'll need to know. Okay, at least 3. Questions? Keep on going. Are we okay? So that kind of takes care of both 1 and 2. The slope formula is in there. We have Mr. Slope on the side. We have all the different ranges of slope there. Just being able to interpret it is going to be key with that. So just kind of keep that in perspective as we do this. Moving along, yeah, we're okay? Mom, we all right? Okay, here we go. So I'm going to skip this problem. Same thing, rise over run. But we're going to look at slope intercept. And slope intercept is one of the lines that we have to do. This is slope. Slope intercept, which goes from y is equal to mx plus b, where m is your slope and b is your y-intercept. The way that we usually graph this is we do graph y-intercept because it's always easy to find out. And the second portion of that would be to say graph or plot slope from, I'm going to abbreviate this, y-intercept. You guys okay? You guys need help? Are you guys okay? Okay. Which one is John? What's up, boys? How you guys doing? Good. Good. Good.
Yeah, today.
Yeah.
I made like almost all my zeros.
That a boy? Bring up those grades, baby. Love it. Woo! Let's see, boys. You okay? Are you guys need help? Are you got it? Okay, okay, okay. So that's how we want to be able to do those to graphing slope intercept. If I'm looking at this one first and my graph is going to kind of, it's in the slope intercept form, so I notice that it crosses at my y-intercept at -4. So A and D are already crossed out because those are not going to help us. But then I want to be able to find my rise over my run. If I go up to and over 1, it follows my slope that my slope is going to be 2 over 1. So if I want to write this whole thing out, y is equal to 2 over 1 x minus 4, or y is equal to 2x minus 4. Okay, my slope is going upwards, so I know that using Mr. Slope, I know it has to be positive, so I know it can't even be C. Okay. For my review, this is problem number 11 on part 2. So if you have all these questions with you, so just in case, okay? Just in case. Questions? Is this helping reviewing a lot of the material, guys? Like, yeah? Okay. Trust me, this will help you guys out. I believe it will help you guys out. Okay. Can I move on? We're going to continue. We're going to do point slope now. Point slope equation. This is always a fun one to go over. Okay. So my point slope, is always a fun one to go over, but this is y minus y1 is equal to mx minus x1. Okay, we have our point x1 comma y1, and we have a slope of m. Okay, to graph this, we use opposite x and y's. And we use the same slope. To graph it, plot point, graph slope from point. How you doing over here? Good night. You junior or sophomore? Sophomore. Junior. That's crazy. But I had her too, but she got my class related. Did you? Miss Jackson's cool. I like Miss Jackson. She's funny. Okay, so the question that we have here, it's asking us to find the point slope method with this. What we got to be able to do is find our slope. So our slope will be 4 minus 1 all over -2 minus -1, which would give me 3 over cube change flip -1, or m is going to be equal to -3. And we have my point -1, 1 that I want to use. So we're going to take that and we got to plug it back into our point slope formula, which is y minus y1 is equal to mx minus x1. I want to be able to use the opposite points when plugging back in. So my y version will be +1 will be -1. My slope remains the same as -3. X is -1, so its opposite is +1. So that's all we want to be able to see from that. A and C are the same, so we really don't want to be able to see that. At least the same slope, which is not our slope. And the one we're going to look at is how we want to be able to see the opposites. In this case, it will be B, because our X will be +1. Are you guys okay?
Yeah.
Make sure you guys sign up for me real quick. I would love to do math 3. I would love to. I taught math 3 my first year I was here, but because I'm integrated math 1, if they give me the opportunity, I'd love to do math 3 because I think it'd be a lot of fun.
Who else does math?
Yeah.
One of the teachers in one. Yeah. I heard Lee's good.
Lee's good. Lee's good. He's a pretty good teacher. Scranton is good for integrated 3. Miss Man is hard. Miss Man is hard. Miss Bonneville. Miss Man is pretty tricky. Miss Man is pretty tricky. Mr. Lee, I believe, teaches honors. Mr. Scranton teaches honors. So those two teach honors. I mean, the other ones are not bad. They're just, I think that Mr. Lee, I mean, he's always here after school. And he's always tutoring kids, and he's really dedicated. And Mr. Scranton, we'll get there to you guys too. So I mean, all the teachers are good. It's just, your preferences. Come back and see me, and I'll try to figure those out. Okay. Bye, ladies. We'll see you guys.
Thank you.
Okay. Here we go. Standard form. Okay, for standard form here, we're going to look at our standard form of our equation of a line ax plus by is equal to c. The best thing I'm going to say for you guys on this one is solve, S-O-L-V-E, solve for y. And just go ahead and go back and put it into y equals mx plus b because it's going to be easier for you to see. Done. I mean, that's going to kind of be how it is going to be. And that takes care of your intercepts, knowing where to identify your intercepts from. If I'm looking at my equation here, 3x plus 4y is equal to 12. We're basically solving for y. So this is a two-step problem. We're going to go ahead. This is don't call Mexico after midnight. So we're going to go ahead and say distribute, no. Combine like terms, no. Move small value of x. So we're going to subtract out 3x from both sides. Boom there. 4y minus 3x plus 12. And it almost looks like our y equals mx plus b besides that 4 right there. But what I want to be able to do is just divide that out by 4. So that's our last portion that we're going to do here. I'm going to divide each term by 4. So negative 3 by 4 and my 12 by 4. When you reduce down, you're going to get y is equal to negative 3 over 4 x plus 3. Where it tells you your intercepts already, it tells you your values. In this case, my slope was not negative. It has to be this, has to be b. To find the intercepts of this method, so the intercepts would be cover-up method. If we cover up the x, we're going to get y is equal to 3. If we cover up our y, our x will be equal to 4. Our intercepts would be 0, 3, 4, 0. So that's just, I'm going to throw it out there. I forgot whether there's problems like that on the test. I want to say there is, but that's going to be the method to how to solve it. So cover-up method does work for that part. Also being able to identify. Sorry. Good? Moving on? Are we okay? You still copy? Still copy? Okay. Nancy. Ready to go home. 12. What time do we got? 11:15? Yeah. Don't do stuff or do stuff? Oh, of course. Yeah. Yeah. I'm going to skip 6, but we're just going to do quickly looking over the graphic inequalities. 7 is just intercepts, being able to identify the intercepts, right? Y equals mx plus b, the intercept of that. Okay. Looking at the next one. So we're going to skip the intercepts. In this case, our intercepts for our y-intercept would be at 0, 2. So it'd be b. I'm not going to have you guys worry about that. Well, it's one of the questions. The one that I kind of want to go over is graphing inequalities. Just being able to remember how to do them is crucial, being able how to graph them. Graphing inequalities, we say that if your number is less than or greater than, it is a dashed line or dotted line. It's going to look something like this, where the inequality will look dotted. If it is less than or equal to or greater than or equal to, it's a solid line. And this one will look like this, doing in blue, solid line. We usually, to graph it, we usually just say, graph the line, graph line to test point. Our test point that we're usually going to use is 0, 0. We're not going to do anything off it where it crosses at the line, so I'm just going to keep it at 0, 0. And the 3 would be to test it, or test point for true, false, and shade. We're definitely given the inequality for this line, and they're all the same. We just got to be able to find out the inequality. So that's our graph line. We just got to be able to find out what goes on the inside of that. If I'm looking at this, this is actually a solid line, so I know that there's going to be an inequality line underneath it. So B and D kind of go away. Our test point is down below. So this will be my true side. The top side will be my false. So I want to make sure that this statement is true when I plug in 0, 0. So 0, 0 plus 1, 0 and 1. I want to make this true. So 0 is less than 1. So my inequality must be less. In this case, C. And it would be shaded below. So just something to think about as you're doing these. Woo! You still got the backside? Oh, there you go. There you go. That covers the second session. I think the last part of it is going to be pretty easy. Yes? Question?
The slope is undefined. How do you know which side to choose?
Still use your test point. So if I had it, so let's practice that. Let's have an idea of that. So that's good. That's a good one. So let's say I'm going to erase this, and we'll just do a small little practice problem like right here. Okay? And let's say my line is going to give me this. Let's say this, here, that, here. And let's say I give you a vertical line where x is less than 2, right? I told my kids to use Hoy bucks, so we're going to use bucks for vertical lines at 2. So something like this. That's how it's graphed, right? And you're telling me I need to find out what side is shade, or I'm going to freak out and not pass, okay? Use the same test point. What's our test point? 0, 0. So 0, 0 is still going to be there. And now if I'm on this side, if I'm on the 0, 0 side, I'm going to say this side is going to be true. Whatever's not on this side, I'm going to say the back side will be false. So I got to be able to determine that in order for me to continue. So when we plug it in, so let's go ahead and plug in 0. Is 0 less than 2? Is that true or false? Is 0 less than 2? Yes. So because the statement is true, we shade to the true side. Yeah? No? You okay?
Yes.
Yeah? Okay. Yes. Either go for it. Always true. The side with the 0, 0 will always be the true side. So if I would have graphed this and gone back, so let's talk about another one really quick. And let's say I erase this, not that one. Let's say I block this out. And we come up with another quick idea, and this goes back to Hoy bucks, right? This comes back to Hoy bucks, where my inequality is graphed this way. And let's say I have another one where it's this. Let's say it is y is greater than or equal to 3, okay? Let's say this one. It's graphed at 3. It's a horizontal line. We're good. If I do the bottom now, if I do my bottom, okay, let me kind of move this around. Okay, I'm still going to use my true statement. So my y, let me kind of erase this more because I'm kind of getting confused. So my test point is still 0, 0. This is below my graph now. So this bottom side would be true. The top side would be false. And we're still going to test it. When I test, is 0 greater than 3? Is this true or false? False, right? So because this time it's false, we shade above the line. Yeah? Okay. Is it easier to remember?
Yeah.
That's all you got to do. That's all you got to do. Yeah. Yes. Yes, vertical is up and down. Unless, let me clear that. Let me clear this up for you. So the one thing that I would add to your thing too is Hoy and Vux, where Hoy is horizontal, a slope of 0 for Y numbers. And the way that it would look is it would look horizontal, something like this, a horizontal line this way. If you had to do Vux, Vux is a vertical line, a slope that is undefined, UND, for values of X. And let's say my up and down. I'm going to post it online. So I'm going to email it all to you guys today. So, cool? Okay. And I'm going to shoot this email over to Vessup and Dirksen, or Vessup and Jealous and everyone so they know too. So, you guys, where you guys going? Oh, that's right. You told me. Okay. Okay. So actually having these down on them as well would be very key and crucial for them. Okay, so close the door, you guys need to. So it's kind of getting a little wacky. Thank you guys. Yep. Okay. So have those down would be very important as well. Okay, having those down would be very important. Okay. Cool beans? Continue? Okay. Domain and range. I'm going to cover domain and range, continuous and discrete, all in this slide because it's really not that hard for the ones in the test. I believe the part 3 of your final is probably the easiest portion out of everything because all you're doing is you're looking at graphs, you're looking at different values, and you're telling me, is it a function, yes or no? I think this is the easiest portion. 8 or 9 questions are just, is it a function, yes or no? Okay. So let's talk about this. Let's do, and we'll still solve this. Domain. All its values, range. All Y values. We talked about as well as continuous. Continue. I know I spelled that wrong and I apologize. I'm not an English teacher here. Continuous is a line without points. And I'm going to go ahead and just draw a quick little graph of it. It's going to look something like this. We can just kind of graph it without picking up a pencil. And then discrete is points. And I'll do a small another one, or it's going to look something like this. So continuous and discrete are very key and crucial for those. So one thing that we want to say is continuous. Domain and range. So D and R, you want to be able to write as a list as a set of inequalities. So less than X less than Y, or less than, sorry, value. So it looks like that. For range, and this would be domain and range. Discrete domain and range are points. An example would be like your X values would be equal to 2, 5, 9, 11. Your Y's would be -2, 6, 8, 5. Okay, it's just a set of points. We always go left to right, then bottom to top when plugging them in. This question that we have over here is number 6 on part 3. Basically what it's asking you is for the range, which is all y values. The one method that I showed you guys how to do is the box method for continuous. So this is box method. And what we do is we put a box around my values and see how far they go up, which is 80 and 30. It's in the y range, so it would be C. Okay. Wasn't too tricky to kind of figure out and do, but it was just a good one to go over and kind of assess. Cool beans? Okay. So that's what you got to know. I'm not gonna spend too much time on what it means to be continuous or discrete. Know that just continuous is a line that can be made without picking up your pencil. Continuous is discrete means just dots or points. So that's what you got to get out of that. It's not simple. Is it continuous or discrete? Okay. The one that would be very helpful to go over, talking about the next one, would be something like this. Is it a function? Okay. This would be discrete points. Okay. And asks you which scatter plot shows a relationship between x and y that represents two square. One thing that you want to say is as the test scores increases, the number of answers incorrect drops. So in this case, it would be B. This is more of a stats question, but I just wanted to relate that it would be a continue or discrete function. Yes. It will ask you. It will say the next one right here. Something like this is what kind of questions you'll have. So it will be: is it continuous? Is it discrete? Is it a function? Yes or no. So in this case, is a relation a function, or which diagram is not a function? Okay. One thing that we're looking up here that you got to know is a vertical line test, which is a vertical line that passes through only one point. So in this case that we did here, the vertical line would pass through C because it only passes through that one point here. D is the same thing. Anywhere on that graph passes through one point. Even with B, passes only through one point. The second we go to A and we do a vertical line, it passes through 2 points. So this will make it not a function. So that would be A. Does that make sense? That's what we want to be able to see. So basically put your pencil on the paper. If it only goes through 1 point on that paper, you're good. And that's what you want to be able to see when doing that. But those are the type of question. Which relation is not a function or is a function or that kind of thing. Those are going to be the key ones that you're going to want to look at. Okay. Four and five go hand in hand together, meaning that they're mostly going to be the same questions that are going to be asked, where you got to be able to tell me, is it a function, meaning one input to one output for a mapping diagram? Is it a input to output, a graph, input to output table, input, some mapping kind of idea. And that's what I think this portion makes up maybe 8 or 9 questions alone, which is 4 and 5. And let's go ahead and do the next one. So that's why I put these 2 on here. And that's understanding one-to-one functions is for it to be a function, function 1x to 1y. 1x to 1y. Another way to say this is x goes to the same always. That'd be another way to say it. So looking at my coordinate points for number 11, I know that 8 goes to 2, 3 goes to 6, 7 goes to 5, and I'm trying to look for k that goes to 4. So what values can I input that will make it true? So if I put 4 in here, that'll make it a function. Okay, 1 input to 1 output. If I put 3 in there, which is going backwards, if I put 3 in there, 3 goes to 6, but then 3 goes to 4. This would make it not a function, so that would be my error. Okay, the one right next to it, so it's telling me which relation is a function. 1 goes to 2, which is fine. 2 goes to 2. 3 goes to 3. 4 goes to 3. Each of them go to their own. The second I have something like C, where 4 goes to 6, but 4 goes to 8, that would make it not a function. 1x to 1y. 1x to 1y only. Okay. This one, next one, 2 goes to 6, 2 goes to 5, would make it not a function. 1x to 1y. And our last one down here, either one, 1x to 1y. Makes it not a function. Make sense? Easy? Yeah? No? Mine. All what I want you to be able to see here, Maya, is this. Every single time, look at these as their own problem. So don't look at anything else. 2 should always go to what? 2 should always go to 6. Every single time you plug in 2, it should always give you 6. But what happens when you plug in 2 again? Gives you what? Not a function. It fails. Right? Even though these ones, so 1 goes to 2. So every single time you plug in 1, it should always go 2. Okay? That means 2 should go to, does x go to only 1y? It's a different number than 1. It's fine. And they go to the same output, it's fine. But we're only looking to making sure that each value goes to only one output. They can go to the same one, but it can't go to any other one. Right? 3 goes to 3, 4 goes to 3 as well. They're all different x's. We're okay with that. Looking at this one, 1 goes to 2. So every single time I plug in 1, I should always get, when I plug in 2, 2 goes to 4. Am I okay with that? Yep, I'm okay with that. 4 goes to, and then 4 goes to 8. That would make it not a function because you're going to a different value. Make sense? That's what I want you to see. Good stuff, guys? Is it helping out? Yeah? You're for Mr. Vessups? What period for Mr. Vessups? 6? Cool. Oh, you have the last class of the day. Ooh. Ooh. That's hard. That's really. I'm sorry.
No, it's just like in class. I'm okay with that, I guess. But like those are the 2 hardest things.
Right. I'm happy. That makes me happy. It took me a long time to get math too, so don't forget. I make math fun. I hope I do. I hope I do. Right now, it's not fun. This stuff is not fun to go over right now. I get it. I get it. Okay. That was like me. That was like me. Okay. One thing that I want to also go over here is being able to identify the values. This is function notation that we talked about here. I think this one was the easiest portion out of them. you have two of them very similar to this, so you want to be able to kind of go over them and kind of dictate. Grab some food. Yeah, grab some. I'll just put some back there. Okay, this one is a function value notation. So I told you guys anything that's inside this little f, this -3, we're going to go ahead and plug back into my function. So I'm going to take that, I'm going to plug everything back into here. So anything that I see in there will be plugged in there. So -2, we'll see a chat. So as I'm doing whatever I see that x, I'm just substituting that value in. Okay, and then order of operations, I'm going to do -2 times 3 squared, which would just give me 9, plus 6. Order of operations again, -18 plus 6. And then combine like terms with our last one would give me -12. You could plug these into your calculators directly as long as you know what number you're plugging into, and it should give you the good value. What I would highly recommend is you put parentheses around your numbers. When you put parentheses around your numbers, it just clarifies that this is its number. Right? So just do that. Okay? That's what you want to do. So that was kind of key and important. You have 2 of them on your test like that, so you definitely want to be able to do those in that way. So once you have that square root sign, you're going to put the parentheses like that. I don't know if this does x's. I don't know if this does x's. Wish you would. Okay. Okay. Our last bit here. Part 4, median mode range, 5-number summary. Okay. I'm going to give you guys a lowdown on this as well. Just for the first part, I'm just going to tell you what kind of questions, and then we'll just ask you, find the range, find the mode, find the median. I think that's another easy portion of the test. Part 4 and part 3, I think are the easiest. Graphing part might be the hardest one out of all of it. But for here, I'm going to write these out. I'm going to say add numbers up, add numbers, divide by numbers added. Okay, median, middle, number, mode, most occurring number, range, biggest number minus smallest number. Boom. Biggest number minus smallest number. Done. Okay. Those are what you have to be able to do with those for them. Okay. In this case, the most number that happens the most oftentimes is 2, which is 90. Okay, so being able to look at those are going to be very crucial and important. Yes. Categorical and quantitative, yes. Yes. That'd be a brilliant way to kind of do it too. Okay. Skipping this next one, so doing this, not skipping, but doing this next one. Our 5-number summary. I'm going to kind of do it all. So we have I don't know what's happening here. Give me a second. So it kicked me off. What time you guys got? 11:44. We'll get done right now. I think this is the last bit because I think just analyzing data will be easy. This will be the last bit. If you guys want to leave early after this, we'll leave early. Cool with that? Okay. Does this help you out? Yeah? Good. Smallest number is our lower extreme. Our Q1 is our median of lower half. Then we have median, or another way to say this would be Q2, would just be the median, middle. And then Q3 is the median of upper half. And then our upper extreme is our largest number. If you had to do a box and whiskers plot, and this is kind of how it's going to be. That your lower extreme will be at your farthest left. Your quartile 1 will be at your starting of your box. Your median will be the middle. Quartile 3 will be here. And your upper extreme will be here. So you just want to be able to look at the box and whiskers. Yes. He didn't go over this with you guys. Yeah. I know that he's going to change it for you, or he's going to tell you just don't do those problems or just give the answers. Because you've never done this, right? You guys never done this. You guys are a little bit behind this. You guys have bought mean, median, mode, and range, right? Yeah. I think that's about as far as you guys have done. We covered this, and that's it. Like that's about it. That's about it. Bar charts, I just want you guys to analyze and do. The ones on the practice test were a lot harder than the ones on the test. So I don't even want to go over those and confuse you guys. So I'm just going to leave it like that. I would have just not. The ones on the test are very easy. It's given the box data, what color was chosen the most, that kind of thing. So it's just like, no forget. Okay. I just want you guys to make sure that you guys are analyzing this. So this would be a good part to have on. Okay. And that's it. That's all I want to cover because I don't want to confuse you guys more than what you need to know. If you guys can get that, the mean, median, mode, and range, you are golden. super golden. Okay.